Hello students, hope you are familiar with the words perimeter and area of plane figures. Already in your previous classes, you have studied about the area and perimeter of plane figures such as square, rectangle, triangle, etc. We have also learned to find the area of pathways or borders in rectangular shapes. Let us extend this to find the area of some other quadrilaterals. So, today we are going to learn about areas of quadrilaterals. Before starting, let us quickly recall what we have studied in our previous classes. Perimeter. Perimeter is the distance around the boundary of a closed figure. We know that for a square of side A units, perimeter is equal to 4A units. Perimeter of a rectangle of length B units and breadth A units is 2 times A plus B. From these examples, we can say that the perimeter of any polygon can be obtained by adding all the sides. That is, perimeter of a polygon is equal to sum of all the sides. Now, let us see what area is. Area is the region covered by a closed figure. Area of a square of side A units is equal to side into side, which is equal to A into A square units. Area of a rectangle of length B units and breadth A units is A into B or AB square units. Similarly, area of a triangle with base B and height h is half into base into height, which is equal to half BH. Moving on to parallelogram. Area of a parallelogram with base B and height h is equal to base into height, which is equal to B into h. Finally, area of a circle is pi r square, where r is the radius of the circle. Today, let us try to find out the area of some more shapes. Come on, let us watch this video to find out how two students have arrived at the formulae for the area of various quadrilaterals. Hello students.
Hello ma'am.
Can you tell me what is this shape?
Trapezium.
Good. This is a trapezium. We are going to find out the area of a trapezium today. Can you find out the area of this trapezium? The parallel sides are given A and B and the height is given. You can divide this into any of the shapes of which you know to find out the area.
Ma'am, I can divide it into two triangles by cutting the diagonals.
Good. Now, how can we find out the area?
Area of trapezium ABCD is equal to area of triangle ABD plus area of triangle BCD, which is equal to half into base AB into height h plus half into base DC into height h, which is equal to half into h into AB plus CD, which is equal to half into h into A plus B, which is equal to half into height into sum of the parallel sides.
So, the area of a trapezium is half into height into sum of the parallel sides. Now, could you also find out the area of trapezium?
Yes, ma'am. I got the same formula but in a different way.
Good. Same formula in a different way? Quite interesting. Can you explain how you got the same formula in a different way?
Yes, ma'am. I marked the midpoint of side BC as x. That is, BX is equal to XC. Then join AX and cut it through AX. I marked this point as A dash. Attach this piece with XB coinciding XC. Thus, the trapezium got converted into a triangle with the same height h and base A dash B plus CD, that is A plus B. So, the area of triangle ADA dash is equal to half into height into base, which is equal to half into height into A plus B, that is also equal to half into height into sum of the parallel sides of the trapezium.
So, you too have got the area of a trapezium as half into height into sum of the parallel sides. So, we have seen that we can arrive at the same formula in two different ways. But these are not the only ways to find the area of a trapezium. Look at this trapezium ABCD. Here, AB and CD are the parallel sides and h is the perpendicular distance between them, that is the height. Now, let us draw a line segment BE starting from B and parallel to AD. What did we get? Yes, we got a parallelogram ABED and a triangle BEC. But how do you say that ABED is a parallelogram? Correct, because AB and DE are parallel as they are the parallel sides of the trapezium, and we have constructed BE parallel to AD. So, this is a quadrilateral with both pairs of opposite sides parallel. Therefore, it is a parallelogram. Now, the area of trapezium ABCD is equal to area of parallelogram ABED plus area of triangle BEC. Now, tell me, what is the area of the parallelogram? Yes, it is base into height. And what is the area of a triangle? Correct, half into base into height. Here we can see that the base of the parallelogram ABED is DE and that of the triangle BEC is EC. Also, the height of both the parallelogram and the triangle are same as h, that is the height of the trapezium. So, the area of the trapezium ABCD is equal to DE into h plus half into EC into h. Here, DE will be equal to AB. Do you know why? Yes, they are the opposite sides of the parallelogram, and we know that the opposite sides of a parallelogram are equal. Also, EC is equal to DC minus DE. Thus, we have seen that the area of a trapezium can be obtained by dividing it into a parallelogram and a triangle also. Now, let us extend this to a general quadrilateral.
Yes,
Now, we have a quadrilateral ABCD. We can divide this quadrilateral ABCD into two triangles by drawing a diagonal. Now, can you tell me how we can find out the area of this quadrilateral?
Yes, ma'am. Area of quadrilateral ABCD is equal to area of triangle ABD plus area of triangle BCD.
To find the area, we need to draw a perpendicular
to the base from the opposite vertex, that is AP and CQ are the heights of the triangle ABD and BCD respectively.
So, the area of quadrilateral ABCD is equal to half into BD into AP plus half into BD into CQ, which is equal to half into BD into AP plus CQ, which is equal to half into diagonal into H1 plus H2, where H1 and H2 are the heights drawn to the diagonal.
Good. So, you have got the area of the quadrilateral as half into diagonal into height 1 plus height 2. In the same way, can we find the area of this rhombus ABCD?
We can divide the rhombus ABCD into triangles by cutting it along the diagonal BD.
The diagonals of the rhombus are perpendicular to each other.
So the height of the triangle ABD is equal to AO and the height of the triangle BCD is CO.
Area of rhombus ABCD is equal to area of triangle ABD plus area of triangle BCD, which is equal to half into BD into AO plus half into BD into CO, which is equal to half into BD into AO plus CO, which is equal to half into BD into AC.
Here, you might have noticed that the diagonals of the rhombus are also the heights of the triangles. Hence, the area of a rhombus is half the product of its diagonals. In this way, we can find the area of any polygon by dividing it into triangles. This method is called triangulation method. Thank you, children.
Thank you, ma'am.
Hope you are clear about how to find the area of various quadrilaterals. Now, let us solve some problems based on these formulae. Are you ready? Let's start. Example 1. The area of a trapezium shaped field is 480 square meter. The distance between the two parallel sides is 15 meter and one of the parallel side is 20 meter. Find the other parallel side. Solution. Let us draw a rough figure. Here is the rough figure. One of the parallel sides of the trapezium is given as 20 meter. Let it be A. A is equal to 20 meter. Let the other parallel side be B, which we need to find out. The height h is equal to 15 meter. Also, the area of the trapezium is given as 480 meter square. We know that area of a trapezium is equal to half into height into a plus b. Substituting the given values, we will get 480 is equal to half into 15 into 20 plus b, which is equal to 480 into 2 divided by 15 equal to 20 plus b, or 64 is equal to 20 plus b. Hence, b is equal to 64 minus 20, which is equal to 44 meter. So, the other parallel side of the trapezium is 44 meter. Completed? Here is another example for you. Example 2. Find the area of quadrilateral Pqrs shown in the figure. Did you observe what is given? Yes. One of the diagonal is given as 5.5 centimeter. The heights drawn to the diagonal are given as h1 is equal to 2.5 centimeter and h2 as 1.5 centimeter. Area of quadrilateral Pqrs is equal to half into diagonal into h1 plus h2. This is the formula to find the area of a general quadrilateral, which is equal to half into 5.5 into 2.5 plus 1.5, which is equal to half into 5.5 into 4, which is equal to 11 centimeter square. Moving on to a rhombus, here is an example for you. Example 3. Find the area of a rhombus whose diagonals are of length 10 centimeter and 8.2 centimeter. Solution. It is given that the diagonals D1 is equal to 10 centimeter and D2 is equal to 8.2 centimeter. And we know that area of the rhombus is equal to half into D1 into D2, which is equal to half into 10 into 8.2, which is equal to 41 centimeter square. Hope you are clear about finding the areas of quadrilaterals. Let us try to find the area of another polygon where we do not have any formula as such, but we can divide the polygon into shapes for which we have the formulae. Let us try to do this. Example 4. There is a hexagon MNOPQR of side 5 centimeter. Now, you need to find out the area of this particular hexagon. Also, the distance from N to Q is given as 11 centimeter and the distance from R to P is given as 8 centimeter. Now, two students, Aman and Rithima, are trying to find the area of this hexagon in their own way. Let us see how did they arrive at the area in two different ways. Solution. Aman's method. Aman divided the given hexagon as shown in the figure. Since it is a hexagon, NQ divides it into two trapeziums, and if you do a paper folding activity, you will see that they are two congruent trapeziums. MNQR and ONQP are the trapeziums formed by dividing the given hexagon through NQ. Here MR and NQ are the parallel sides of the trapezium MNQR. Also, it is given that MR is equal to 5 centimeter and NQ is equal to 11 centimeter. Since RP is equal to 8 centimeter, the height of the trapezium RS will be equal to half of RP, which is equal to 4 centimeter. So, for the trapezium MNQR, we can find the area as area of the trapezium MNQR is equal to half into height into sum of the parallel sides, which is equal to half into RS into MR plus NQ, which is equal to half into 4 into 5 plus 11, which is equal to half into 4 into 16, which is equal to 32 centimeter square. Now, the area of the hexagon will be double the area of this trapezium, because we have divided our hexagon into two congruent trapeziums. So, the area of the hexagon MNOPQR is equal to 2 times 32, which is equal to 64 centimeter square. Now, let us see how Ridhima found out the area of the same hexagon. Ridhima's method. She has divided the hexagon into two triangles, triangle MNO and triangle RPQ, and a rectangle MOPR. By paper folding activity, she found out that triangle MNO and triangle RPQ are congruent triangles with altitude, that is h is equal to 3 centimeter, and the corresponding bases MO and RP are equal, which is equal to 8 centimeter. Therefore, the area of triangle MNO is equal to half into base into height, which is equal to half into 8 into 3, which is equal to 12 centimeter square. Since the triangles are congruent, area of triangle RPQ is also 12 centimeter square. Now, for the rectangle MOPR, length L, that is equal to RP, is 8 centimeter and breadth B, that is OP, is 5 centimeter. Therefore, the area of the rectangle MOPR is equal to L into B, which is equal to 8 into 5, which is equal to 40 centimeter square. Now, we can find the area of the hexagon by adding the areas of these two triangles and the rectangle. Let us see what is the total area. area of the hexagon is equal to area of triangle MNO plus area of triangle RPQ plus area of rectangle MOPR, which is equal to 12 plus 12 plus 40, that is 64 centimeter square. Here we can see that even though Aman and Ridhima had used different methods, they have got the same answer. So, you can also divide the given polygon into any of the shapes of which you know the formula and find the total area of the given polygon. Now, let us summarize what we have learned today. The area of a trapezium is equal to half into h into a plus b, where a and b are the parallel sides of the trapezium and h is the height or the perpendicular distance between them. The area of a general quadrilateral is equal to half into diagonal into h1 plus h2, where h1 and h2 are the heights drawn to the diagonal. The area of a rhombus is equal to half into d1 into d2, where d1 and d2 are the diagonals. Also, we have arrived at these formulae by triangulation method, which can be used to find the area of any polygon. So, we have learned many formulae today, and also we have tried some examples where we learned how to solve simple problems to find area using the formulae that we have studied. Here are some more problems which you have to try out on your own. Solve. The shape of the top surface of a table is a trapezium. Find its area if its parallel sides are 1 meter and 1.2 meter and perpendicular distance between them is 0.8 meter. Second one, the diagonals of a rhombus are 7.5 centimeter and 12 centimeter. Find its area. So, I hope now you are confident of solving problems related to area of quadrilaterals. Keep exploring new methods, different ways to solve the same problems. Thank you and have a great day.